Hello everybody and welcome. I got a special video for you planned today. Today we're going to be proving the law of cosines. Pretty excited for this one. I've always enjoyed proofs. So the law of cosines is pretty much a generalization of Pythagorean's theorem. So we all know and love Pythagorean's theorem, a squared plus b squared is equal to c squared. So what is the law of cosines? Well, the law of cosines is that a squared plus b squared minus 2ab times the cosine of theta is equal to c squared. So we should all remember that Pythagorean's theorem only works for right triangles. The law of cosines works for any triangle, so it can help us solve for the missing side length of any triangle, given that we have two of the side lengths already and we have the angle opposite the missing side length. Okay, so this video is all about a proof. So let's get to proving. Let's prove the law of cosines. Okay, so I already drew this triangle for us. So we have some triangle and we have A, B, and C labeled as the full sides. Then I dropped this altitude. I labeled the altitude X. I labeled this smaller part of this left-hand triangle Y, and then we have some angle theta. So let's talk about some things we already know. Well, what would sine of theta be? Sine of theta would equal to x over a, the opposite side over the hypotenuse. Cosine of theta would equal to y over a, the adjacent side over the hypotenuse. And what are we trying to solve for? Well, again, the law of cosines is a squared plus b squared minus 2ab times cosine of theta is equal to c squared. So we're trying to solve for c squared. So let's use Pythagorean's theorem to help us out. What do we know? We know that, well, c squared is going to be equal to what? It's going to be equal to x squared plus it's going to be equal to b minus y squared, as b minus y is this distance. So next, what can we do? Well, hey, we have an x term here and an x term here. So let's solve for x. We can multiply both sides by a to have that x is equal to a times sine of theta. And let's go ahead and solve for y and have that y is equal to a times cosine of theta. Now let's plug in for our x and our y. Here I'll go back to white. Let's plug in and we can have c squared is equal to x squared. We found x to be a times sine of theta. This is squared plus b minus y, which we found to be a times cosine of theta. And this is all squared as well. Now let's just expand and simplify. So we have c squared is equal to a squared times sine squared of theta plus, and now we're going to have to FOIL this term, and whenever we FOIL it, we're going to get b squared minus 2ab cosine theta plus a squared times cosine squared theta. All right, now let's group our a squared sine squared theta and our a squared cosine squared theta together. And let's factor out the a squared. And whenever we do that, we'll have c squared is equal to a squared times sine squared theta plus cosine squared theta. And then our remainder is the plus b squared minus 2ab cosine theta. Now, this is a trigonometric identity. Sine squared theta plus cosine squared theta is equal to 1. So this all cancels out. This goes away. Let me quickly prove it to you guys that this is equal to 1. I just want you to think of a right triangle. Let's say we have some right triangle. We have A, B, and C. We know Pythagorean's theorem tells us a squared plus b squared is equal to c squared. And so if we divide both sides by c squared, what will we have? Well, we're going to have a over c squared plus b over c squared is equal to 1. And then, but what is a over c? And what is b over c? Well, it's just it's one of your legs of your triangle over the hypotenuse. And so in other words, this is sine squared theta plus cosine squared theta, and it equals 1. So there's a quick little proof that this trigonometric identity is equal to 1. So it all cancels out, and we are left with what we're searching for. The law of cosine, c squared equals a squared plus b squared minus 2ab cosine of theta. So there is our proof. Hope you guys enjoyed it, and I'll see you in the next video.